Today, we're doing math analysis, Chapter 2, Section 2, Solving Right Triangles. I'm your host, Dr. D. Okay, what it means to solve a right triangle is that you're going to find all the angles and all the sides. Now, if you're given a right triangle with one angle and any other part of the triangle, then you can solve the whole triangle. Here's an example. We have a right triangle with a 30-degree angle. Now, if you know that angle C is 90, angle A is 30, you know that angle B has to add up to 180, or just A and B have to add up to 90. So that's the first thing we know, that angle B equals 60 degrees. Now, we really should be writing the measure of angle B equals 60 degrees, but that's what this notation is going to denote. Okay, so now we need to find side B and side C. So first thing, this is a pretty simple example because angle A is a 30-degree angle. That means we have a 30, 60, 90 right triangle. That means the short side is always 1, the hypotenuse 2, and the long leg is square root of 3 times the short leg. So we basically have it all right now. You know side C then has to be twice as much as side A, and side B has to be the square root of 3 times side A. That's it, game over. We have solved the triangle. Okay, let's crank up the juice just a bit now. We don't have a 30, 60, 90 anymore. The other angle is 40. Well, we still know that A and B have to add up to 90, so we know that angle B has to equal 50 in this case. Now, we need a trig function to be able to solve for side B or side C. So let's look at, if I'm trying to solve for side C, then I know sine of angle A equals opposite over hypotenuse, so equals 10 over C. Well, I know that angle A is 40, so sine of 40 equals 10 over C. That means C times sine 40 equals 10, and that means C equals 10 over sine 40 degrees. Now we need a calculator. So you're going to go 10, enter, 40, sine, divide. And C ends up being 15.557. So we'll just say 15.56. And now, one other thing to remember, when you're taking the sine of 40 degrees, you need to make sure your calculator is in degrees. So you go to the mode button and look where it says angle measure. It should say degrees, not radians, not gradients. So make sure that that is the case. Okay, so side C is now 15.56. Now we need side B. Now, the best thing to do is stay with the 10 because it's the exact number that was given. So what trig function can we use with angle A that uses a 10? Well, we have opposite and adjacent, so we have tangent. So here we go with tangent of angle A equals 10 over B. So that means tangent of 40 degrees equals 10 over b. We do the algebra, and b is going to equal 10 over tangent 40 degrees. So that means, back to the calculator, b is going to equal 10, enter, 40, tangent, divide. 11.917. So 11.92. That's it, game over. Okay, now, this time we're given an angle and the hypotenuse. And we're trying to find side A and side B. So we have a similar situation as before, because first thing we do is realize that A has to be the complement of B. So that means angle A has to equal 32 degrees, so that 58 and 32 adds up to 90. And then we need to find side A. Well, notice we've got the hypotenuse, but we don't have side A, so what we could do is take the trig function of B, cosine of B equals adjacent over hypotenuse. So that means A is going to equal, multiply the 25 over here, 25 cosine of angle B, which we know is 58 degrees. So back to the calculator. So we go 25, enter 58 cosine times, and 13.247. So A is approximately 13.25. Now we do side B, and that's opposite hypotenuse. So what we have here is sine of angle B equals opposite over hypotenuse. So that means B equals 25 times the sine of angle B. Okay, so let's just do that. So we have 25, enter, 58, sine times 21.201. So side B is approximately 21.20. Now, one last thing we should do before we quit is look at the numbers we got and make sure they make sense with the triangle. Notice with a 58-degree angle, that's more than 45, so that means side B will be larger than side A, and it is. Next, we want to make sure that both side A and B are less than the hypotenuse, and they are. So this makes sense if you look at the proportions. If the hypotenuse is 25, it makes sense that the long leg is 21.2 and that the short leg is 13.25. Okay, so let's crank up the juice just a bit more. Okay, this time we have a right triangle with two sides and no angles. So clearly, to get the third side, we use the Pythagorean theorem. So that means I'm looking for side C. So C squared equals A squared plus B squared. So that means C equals the square root of 11 squared was 121 plus 7 squared was 49. So C equals square root of 170. So that's another calculator issue. We want an approximation for the square root of 170. And that's 13.038. So 13.04. Now we look at this again. And if this is 11, this makes sense that this would be 13 and this would be 7. So the proportions make sense intuitively. Now we need the angles. Okay, so angle A, what we know is that the tangent of A is 7 over 11. So tangent of angle A equals 7 over 11. Now we need angle A, so we need to undo the tangent function. So what we're going to do is take the inverse tangent of both sides, and so angle A is going to equal the inverse tangent of 7/11. Well, now it's calculator time. So notice the tangent button. Directly above it, you have A tan. Well, inverse tangent is the same thing as arctangent. So arctangent 7 over 11 is going to be the angle that A is. So what we do is we go 7, enter 11, divide, and then we go white tangent button. So angle A is going to be approximately 32.47 degrees. Now, angle B we know is the complement to that, so all we do is subtract that from 90, and we end up with 57.53 degrees. That's it, game over. All right, now, before we move on, I want to make sure that you really understand this inverse trig function. So let's take a look. All right, if sine of some angle equals some value, then that means the angle equals the inverse sine of x, which equals arcsine of x. If cosine of the angle equals x, then the angle equals the inverse cosine of x, or the arccosine of x. And if tangent of an angle equals some x value, then that means the angle is the inverse tangent of x, or the arctangent of x. So there's two different notations that mean the same thing. Inverse tangent, arctangent mean the same thing. Now notice one other thing. If I have sine of A equals x, then what that means is that I have sine of an angle equals a ratio of sides. Okay, now, if I do the inverse, then I have inverse sine of x equals an angle. So notice inverse sine of a ratio equals an angle. So whenever I take the sine of something, it's the angle. That's going to give me a ratio of sides, and in the case of sine, it would be opposite over hypotenuse. Now, when I take the inverse sine, then I'm taking the inverse sine of a ratio, and that will give me an angle. When you take the sine of an angle, you get a ratio of sides. So the sine or cosine or tangent of an angle gives you a ratio. Now, when you're taking inverse sine, inverse cosine, inverse tangent of a ratio, you get an angle. So if I'm looking for a ratio of sides, I'm taking the trig function of an angle. If I'm looking for the angle, I'm taking the inverse trig function of a ratio. Okay, let's move on. Okay, last example, and this one is maximum juice. Okay, so we're given that the hypotenuse is 10 and that side A is 4, and we need to solve the rest of the triangle. So once again, we use the Pythagorean theorem to get side B. So I know that 4 squared plus B squared equals 10 squared. So that means B squared is going to be 100 minus 16, which is 84. So that means B is going to be the square root of 84, which is approximately 9.165, so 9.17. I look at it and that appears slightly high. Let's see. Did I do that right? Okay, 100 minus 16 takes square root. Yeah, that's it. That is correct. Okay, so it seemed like 9.17 is a little bit higher than I felt like it should be, but that just means I drew the triangle not quite to scale. Okay, now we're ready to find angle A and angle B. So what I look at here is that sine of A equals opposite over hypotenuse. Remember, 10 is the hypotenuse. So if sine of A equals 4 over 10, then that means that angle A equals the inverse sine of 0.4. So 0.4 arc sine 23.578. So angle A is approximately 23.58 degrees. And notice the way I drew it, it's a little bit bigger than that. Now, angle B is going to be the complement to that, so I just subtract that from 90, and angle B is going to be approximately 66.42 degrees. That's it. Game over. Have fun with these.
That's all, folks.